What is IMDb? Internet Movie Database is an online database of information related to films, television programs, home videos and video games and internet streams including cast, production crew and personal biographies, plot summaries, trivia and fan reviews and ratings. IMDb is the world's most popular and authoritative source for movie, TV, and celebrity content designed to help fans explore the world of movies and shows and decide what to watch. To begin with, EDA, Exploratory Data Analysis on IMDb Dataset. The dataset files can be accessed and downloaded from IMDb website where the data is refreshed daily. 7 gzipped files can be downloaded from this website, and over here we are only interested in movies. Therefore we won't be going through title.episode.tsv.gz and title.crew.tsv.gz. Let's start with the necessary imports of the Python library. Import pandas as PD, where pandas is used for data analysis purpose, which is built on NumPy package and its key data structure is called the data frame. Import NumPy as NP, and NumPy is used in working with arrays. Import Seaborn as SNS, which is used for statistical data visualization. Import matplotlib.pyplot as PLT, which is used for plotting purposes, and here we have set certain plotting styles such as data grid, etc. Let's examine the tables one by one. Ratings table. The ratings table contains the IMDb rating and votes information for titles. It consists of T constant, average, num votes. In line 2, df_ratings is equal to pd.read_csv followed by the file path. So what is happening here is that read_csv is an important pandas function to read the CSV files, and it does the operations that are related to it. So basically we read the file, and next df_ratings.head. The head function is used to get the first 5 rows of the dataset that we have selected. In line 3, df_ratings.info. This function is used to get the concise summary of the data frame. The ratings table consists of almost 1 million movie ratings entries. The average in line 4, df_ratings.describe. The describe function computes a summary of statistics pertaining to the data frame columns. The average rating is 6.89, which is different from the median value 7.1. We will examine this further. And the average number of votes per film is close to 1,000. This time median is significantly different than the mean. Now, when we come forward, what we get to see is that we get to see 2 graphs. The average rating distribution. It shows a classic negative skew distribution where the median is larger than mean. Vote count distribution is heavily clustered around small values. Therefore, we need to do a little bit extra to visualize this packaged distribution. We take the ratings and we take the votes, and then we plot these figures, and then we plot these figures, and then plot.subplot, and then we set its axis values, and then we plot it according to the layout chosen by us, and then finally we type plot.show. And when we come to line 7, over here what we are doing is we consider plotting the distribution on a logarithmic scale, which reveals more. Since it is a count variable, it looks more like a Poisson distribution, and we have set the y label and y scale, and we have selected the data also. And when we come forward, since IMDb itself provides us with different data set, now we take the data that is available in time basics table. This table basically contains the following information, that is T constant, the title type, primary, original title, is adult, start year, end year, runtime minutes, genre, etc. It is similar to what we have explained before. That is, first we read the data using pd.readcsv command, and then next we use the head function to display the first 5 rows of the data and data set, and when we come down, we use the information function to display all the information using that function. And then title basic table is way larger than the ratings table with over 6 million entries, each of which describes basic information about the video title. I have used the word video as it is not only includes films but also TV CDs, short videos, short films, even video games, etc. And in line 8, a pie chart is being displayed. Majority of the titles are TV episodes, that is 71% approximately, and then movies, including TV movies, only cover 10% of the data set. And then we have done this using plot plt.show. It displays plt.show basically displays the pie chart. Over here we plot a pie chart after counting the title type available in the data set. As you can see, 70% is TV episode, 11% is short, 8% is movie, 4% is video, etc. Now, when we come even more down, what we're mainly focusing is to trim the data set, as we are only interested in movies. After trimming is done, the majority of the titles now are movies, 82%, and the remaining 120k titles are TV movies. As you can see now, and when we move forward to line 12, our main focus is on the distribution of the genre. The pie chart below does not look that attractive, right? It is because movies have multiple genres. Therefore, what we see below is a combination of genre, each representing a slice in the pie. And let's move forward down to the third data set that is available in the IMDb dataset, that is name basics table. It basically contains the information such as nconst, primary name, birth year, death year, primary profession, known for titles, etc. As said above, we'll be reading the data, we'll be displaying the first 5 rows in line 26, and in line 27, the table have almost 10 million names coming from different professions such as actor, actresses, directors, writers, etc. It contains the birth and death year info as well as their most known work of art. And when we move forward, a graph has been displayed. It is basically the birth year distribution of the person in the data set. The data set contains even ancient writers from the year 4 AD. df underscore name underscore basics dot sort values birth year. It sorts all the all the values under the birth year dot head, and it displays the first 10 sets of it. And the distribution of the lifespan of persons in the data set. When we come to line 30, it shows a negative skew where the mode is greater than mean, which is expected for distribution showing age at death, as you can see in the graph. When we come forward down to the fourth data set, that is title principal tables, it basically contains the principal cast queue for titles. It includes tconst ordering, nconst category, job, characters, etc. The process remains the same. We read the data, we display the first 5 rows of it, and then when we come to line 33, a pie chart again has been displayed. It is the largest table has been explained. But before that, when we come to line 32, it is the largest table amongst the other IMDb table with a size of almost 2 GB. It contains over 38 million principal cast crew members such as actors, actresses, writers, directors, producers, editors, etc., which are associated with each film. And when we move forward, Under df underscore title underscore principles dot info, it displays all the informations that are available from that data set. Now let us find out who has been the busiest in the film industry. So for doing that, what we do is under top names we use n constant, value constant, head, and top names we put we take the data frame and then we count all the values, and then again it is merged with n const and the primary name, and then the top names under job type has been taken. And then finally what we get is Ilayaraja and William Shakespeare are the contributors with the highest number. Brahmandam was involved more than 1,000 films as an actor. Other than Shakespeare, not much is known about these personalities. And when we move forward down, we come to the fifth table. That is, it contains information for the following titles for the table title AKA's table. That is title ID, ordering, title, region, language, type, attributes, is original title. The same process has been repeated over here, that is reading the data set and displaying the first 5 rows using the head function. And when we come to line 37, the table consists of titles also known as AKA information, such as variation of title in different countries. There are 19 million rows in the table. And in table 38, we merge the tables such as df underscore title AKs, df underscore table basics, and basically our focus is on those, I mean, like we are only interested in movies. Therefore, AKA's table is inner joined with the title basics table, and then we get the following data. And now when we move forward down, we get a very colorful graph. But what this graph basically means is that, and then we are importing pi country. It is a function that has all the countries in it, that gives us access to all the countries in it. So let us convert these region codes into country names first, and then we count them, and then we visualize the top 20 in this graph. The count does not give a total number of cinemas or tickets. It just basically gives us how many different numbers of films are shown in the cinemas in the country. The higher the number, the more the various films are shown, and US clearly wins this competition, as you can see in this graph. Greece and Hungary finds themselves in the middle of the table. Between them, I would expect something interesting. And now we come to the last, that is merging. Over here we are showing how, and over here I have performed the merge function. It is basically merging title basics, ratings, title principles, and df underscore name basics, all the tables. That is basically all the tables which comes under movies, only movies, are being merged over here. And the data set is huge, and then the final table that we get has around 2.5 million rows and 19 columns. And then to somewhat extent, we have sort of included around 5 to 8 different visualization codes, and then we have included plenty of graphs to visualize the different genres, the countries, and then the people who has worked, who are busy or throughout the year or is over the years. And then now let's move forward to modeling on the same data set. Regression analysis on IMDb dataset. Over here, we are going to study 2 types of regression, that is logistic regression and KNN regression. Basically, it includes 4 steps, that is splitting the dataset, training the dataset, testing, and finally finding the score. To begin with, in step 1, we import the necessary Python libraries, that is import numpy, panta, matplot, lib.pyplot for plotting, cbound for statistical data visualization. Next, we import logistic regression from sklearn, which is for machine learning package. Then we use train underscore test underscore split for splitting database into 2 different data sets. In line 2, we read our respective dataset and display them using head function. In line 3, we check if we have any null value. Line 4 is used for replacing every NaN values with 0. In line 5, we are generating a correlation between columns of a dataset and mapping them using a heat map. In line 6, we are generating features and target. That is, we are generating features of the correlated values and the outcome for that. In this, we have different features, and IMDb score acts as our target. We're training and testing the model over here. So over here in line 7, we split our data set. In line 8, we train and test them. Drop NA command is used for dropping all the columns with null or NaN values, and now we split them into xtrain, ytrain, xtest, ytest. For linear regression model, for classification accuracy, we import linear model from sklearn. We also import matrices for checking the accuracy and error of the model. Linear underscore model dot linear regression helps us to get the linear regression model, and then finally we train our model as xtrain and ytrain, and then lin underscore score is used to find the possible outcome of this. If they are same, then we say that our prediction is almost correct. So finally, when we get our score, if the scores are higher, means we say that our accuracy is also high. So based upon that, we choose our model. So over here, we have also used KNN regression, and for under KNN regression, similarly, we get two types of score, that is training score and testing score. If we get almost similar value, it means that it is correct. And so based upon the accuracy of the scores that we get in different models, we choose our models for the data set. Now, to conclude with, movie success prediction plays a vital role in the movie industry as it involves huge amount of investment. However, success rates of a movie cannot be predicted based on a single attribute. Hence, a model is built based on an interesting relationship between the attributes. Movie industry can take a help of this model to change the movie criteria for obtaining likelihood of blockbusters. Every criteria involved is given a weight, and then the prediction is made based on these. So that's it, guys. The main aim of this video was to introduce you to IMDb Internet Movie Database and the various exploration and analysis that can be done on this data set, and the models that can be performed on the data set for predicting and analyzing, and then these can be used in real time in order to obtain huge gross profit, blockbuster in the blockbustering of the film, etc. Thanks for watching, everyone.